In this lesson, we will learn about the nested list or multi-dimensional list. This is going to be a lengthy lesson since we will try to cover most of the things of the nested list. We will do a couple of practice problems. We will code the famous Tic Tac Toe game. It shall not be a good graphical interface game. The interface will be simple text based, but the logic of course will be similar to what we have in good graphics Tic Tac Toe game. Then we will also discuss about an interesting review question where I will provide you a half completed and main structure of the program and you will complete the remaining logic. You can see the description of this video for the timestamps of different things we will be covering in this lesson. So let's start the discussion. I will create a list A. As we know, a list can have an element of any data type, for example integer, float or boolean. And it can also have another list as its element. For example, here it is a list with elements 2, 4 and 6. And this list is one element of the list A. Let's print the list. And you can see the list contains another list as its element. We call this list as the inner list of list A, or we can also call it as the sublist of list A. Can you figure out how many are the total elements in the outer list, list A? It should be 4. The inner list is the fourth element of the list A. Let's print the length of the list A. And it is 4. Since the inner list is the fourth element of the list A, it means it is at index number 3 inside the list A, and we can access that using that index. There is also a way to access the elements of the inner list. For example, if I want to access this element 4 inside the inner list, for that I know the index of this element inside the inner list is 1. So after this A3, which is referring to the inner list, I can specify the index of the second element as 1. And this is the element 4 inside the inner list. So we need double indices to access an element inside the inner list. The first index specifies the inner list inside the outer list, and the second index specifies the elements inside that inner list. Now as list is iterable, so I can apply the for loop directly on the list A as we did earlier. This will print all elements inside the list A, and the last element itself is a list. Now I will discuss a case which can efficiently be done using the concept of nested list. Here is a program which takes the day and the month from the user and displays the corresponding zodiac sign. The zodiac sign depends on the month and the day in that month. So if it is January, the zodiac sign can be Capricorn or the Aquarius depending upon the day. If the day is 19 or less, it will be Capricorn, and if day is after 19, it will be Aquarius. We have similar scenarios in the other months as well, and the tricky part is that a day segregating the two zodiac signs in one month are not same for each month. For example, in January it is 19, in February it is 18, and so on, possibly different values in different months. So in this code it is solved using different if-else conditions. We are taking the day and the month from the user. Then if the month is January, there is condition if the day is less than or equal to 19 or not, and accordingly Capricorn or Aquarius is selected. And so on for all other months. And finally the result is printed. Now we will do it using the list. Here I have defined a function zodiac with day and month as the input argument. Then this is the nested list. It is one list but written on multiple lines. This list contains a few sublists. This is the first sublist having the two elements Capricorn and 19. It is for January. The sign is Capricorn till 19th of January. Then this is for February and so on. In total it should be 12 sublists, one for each month, but actually it has 13 sublists. After this sublist of December, we have this last sublist and it contains only one element, contrary to all other sublists having the two elements each. We will discuss in a while that why we need this 13th sublist. Let me just print the list outside the function to show you that it is actually one list having few sublists. From this list we can select a sublist, for example index 0 for the first sublist, and we will develop the logic how we can use that sublist to find the zodiac sign. Inside the sublist we can access the first element, which is the zodiac sign, using the index which is 0 in all sublists. Now let's develop the logic inside the function. For each month, the corresponding sublist is at the index 1 less than that month. For example, for January, the month is 1 and the sublist is at index number 0. So firstly, we can select the corresponding sublist using the index as month minus 1. For January, it is this sublist. Now, if the month is January, the zodiac sign will depend if the day is less than or equal to 19 or greater than that. The day information is the second element of all sublists. So I can have a condition as if the input argument day is less than or equal to the segregating day, which is at index number 1, then it means the zodiac sign is the one available in the selected sublist, and that is on the index 0 of that sublist. So I can simply return that. This else means the input day is greater than that segregating day. For example, in January, if it is greater than 19, then it means the zodiac sign is the one available in the next sublist. I hope that makes sense. So in this else, we will return the zodiac sign present inside the next sublist. The next sublist is at index month instead of month -1, so I'll get that from there. Again, the index of zodiac sign in next sublist is also 0. Now let's test it in the main program. Let's test it on the month July. If it is 22nd of July or less, it should be Cancer, and if it is ahead of 22nd, it should be Leo. Let's enter 20th July, and it is correct as Cancer. Now let's enter 26th of July, and it is correct as Leo. This sublist is for December, so if it is 21st of December or less, the sign is Sagittarius, and after 21st it is Capricorn. So for Capricorn in December, we will have to select the first sublist, but the logic we have written is selecting the next sublist. So instead of applying some condition for this special case of this date after 21st of December, what I did is I added another sublist with the zodiac sign as Capricorn, so that the same logic to get the sign from the next sublist should work for December as well. For that last sublist, I have not added the segregating day value, since this sublist will never be selected in the initial step because we don't have a month number 13. Let's check it for December 20. It is correct. And now for December 30. So I hope you got a good idea how the nested list can be really helpful for different logics. In this case, such simple solution was not possible by using simple lists instead of a nested list. Now we will do different tasks which needs processing of the nested list. I am defining a nested list here. The task is that I want to generate a flat list from this nested list. By flat list, it means that there won't be the sublist. It will be a simple list, but it will have all elements of the sublist of the original list. For example, the elements of the first sublist, followed by the elements of the second sublist, and so on till all elements of all sublists. I will start with an empty list. Now I will iterate the list A directly. So what is inside the loop variable I? The loop variable I is the element of the list A, and those elements are lists, and I want to get the individual elements inside those sublists. So again, I can apply the direct for loop on the sublist, which is in the variable I. Let's just print the elements. And these are all individual elements in all nested lists. Now it's very simple. I just need to append those elements in the list flat A. Now you can see it is a simple list. You must take the idea that in case you have a nested list and you want to process each element inside each of the inner list, then you will have to use the nested for loop. Now let me remove this computer from the last sublist. The result is correct because the last element is still a list having only one element as 100. But now if instead of this 100 inside a list, if I make it a simple integer value, so do you think that there will be some problem? This for loop is being applied on the sublist of list A, and the last element is not a sublist but an integer. So we are applying the for loop directly on an integer. So let's see that. And we got the error. Read the error and it tells everything as int objects is not iterable. Remember we said that list is iterable because we can apply the for loop directly on the list, but integer is not iterable and hence we got this error. There can be a solution. For the inner for loop, we can first apply a check that element actually is a list. For that we can use the built-in type function. So if it is a list, we are iterating over and else means it is not a list. By the way, there can be other data types as well which can be iterable. So I am assuming here that if it is not a list, then it is some non-iterable object like integer or float. So in that case, we can simply append that into the list flat A. And now we see the desired result. Now let's see the lab manual. This task says that you have a list having a few sublists and you have to display the one sublist whose sum of elements is greatest of all other sublists. You have to do it by creating a function maxSum. So let's do it over here. I'm just creating a list of sublists with different numbers. This first sublist has a sum of its elements, and so as the second list has its own sum and the others too. And we need to display the sublist having the maximum sum. Let's create a function named as maxSum. The input argument t will be the nested list. I will iterate over the list elements. The loop variable sub will be the individual sublist in each iteration. Because the variable sub is a list, so I can apply the built-in sum function on that to get the sum. I need sum of all sublists and then I will be finding the maximum sum value. So the logic can be storing the sums of all sublists in another list first so that we get all sum values. So here I am defining that list as empty list, and over here I will append the sum value in that list. Let's first see the working of this much logic. So I am returning that list having all sums. Let's test it. And we got the sum of all sublists. For example, 9 is the sum of the first sublist, 22 is the sum of the second sublist, and so on. You can see 24 is the maximum sum in this case, and it is for this third sublist, and actually we need to display this third sublist. So the logic can be very simple. We can find the maximum value of the all sum list, which will be 24 for this case, and then the index of this 24, which is 2, is same as the index of the sublist inside the input list. So let's do it over here. This is the maximum value of the all sum list, and I need the index of this value inside the all sum list. So I can do it like that. Let's save the index in some variable, for example I, and now we need to pick the sublist inside the input list t at this index I. I will return that. Let's run it. And this is the sublist which was having the maximum sum of 24. If I change this 1 to 100, now this sublist has the highest sum, and we got that. Now the next task says that you have to split a list into two parts. The length of the first part will be given, and the original list should get splitted at that number of elements. The next task number 3 is also related to splitting of the list. So I will do task number 3, and task number 2 is much simpler than that. So this task says that you have to split a list at every nth element. You will create a function named as splitlist. The function will take one list as input argument and one number. So if this is the list and we want to split it after each 4 elements, so this should be the output list where the original list is divided into the sublist, each having 4 elements. The last sublist might have less than 4 elements. So let's do it over here. I will first write the main program. Let's take the same example list. And this is the output we need. So let's create the function. This upper A is the output list, and I will start it with an empty list. Now I need to make sublist from the input list lower A, and will keep appending that into the output list. So to generate different sublists of size n, I am defining an empty list to hold that sublist. Now to get different sublists, we will use the list slicing. The first sublist will be the first n elements of the input list. So we can slice that like this. We can append that into the output list. And then we need the next sublist, and that will be the next n elements starting from index n till 2n. We should append this sublist and generate the next sublist, but of course not this way of generating the sublist manually, but we should automate this process. These are the two statements I need to repeat multiple times till the input list is complete, but of course with different slicing indices. So I will write these inside the for loop. The loop variable I will be used as the index of slicing, and I will specify it as 0 to length of the input list, but with the step size of n. so that the first value is 0 and the next is n, and then the next is 2n and so on, and the slicing indices should be now as I to I plus n. Let me first show you the values this range function generates. I'm applying the function with n equal to 3. These are the values generated by the range function. After 0, the value is 3. For 0, these will be from 0 to 3, which will pick the first 3 elements. Then the next value is 3, and this will be 3 colon 6, and it will pick the elements from 3 to 5, which is the second sublist. And so on for the next numbers, the next slice of size n will be picked. So let's return the output list. Now I am applying the function with n equal to 4. And we got the desired result. You can see the last slice is having just one element since no more elements are left. Let's try it with n equal to 3. And now the sublists are having 3 elements. Now in the next task, we need to create a function named as merge sublist. It will have two nested lists as the input argument, both having equal number of inner lists, and the function will merge the corresponding inner list of the both input lists. So if these are the two input lists, both having 3 sublists, then this will be the output list having the sublist as the merged list of the input sublist. I can copy the example list. So these are the two lists A and B. And I need this output where the first sublist of both list A and B are merged as the first sublist of the output, and so on. I'm creating the function m and n are two input lists. I'm starting with an empty list. Now in for loop I have to scan both of the input lists, so I should not iterate directly on the list, and instead I will iterate using the index. I can specify length of any list because we have assumption that both lists are of same size. Now I can access the sublist of list m as mi, and to add the sublist of second list, I can simply concatenate using the plus operator. And then I will append that into the output list. Let's apply the function. And we have the desired result. This concept of nested list can be used to represent a 2D matrix as well. Let me tell you that if you need to work with matrices involving different matrix operations and algebra, then you should use a package named as NumPy. You will have to install that, and there you have the functions for different matrix algebra. That is efficient and handy to work on matrices. We will not do that over here, but just for some basic working and a couple of simple tasks, I will show you how you can do that using a nested list. So if you have to represent this matrix of size 3 by 3, you can do that as a nested list, and each row of this matrix will be one sublist of the nested list, like this. If I print this, it is not printed as matrix shape, so maybe we can print each sublist representing a row on a new line. This looks better, but still the elements are not properly aligned. For that I can access each element inside a row and print that. The elements inside one row should be printed on one line, so I should use the end parameter and set that to an empty string. Then for the next row to be displayed on a new line, I can use a blank print statement after the inner for loop. So that's the output, but we can't differentiate if these are the 3 numbers or one number as 234. So basically I should set some format for these elements. For example, as 6.2f, which means that each number will be represented in 6-digit size and with 2 decimal point accuracy. And now this looks much better as compared to previous output. If I remove one element from the third row, This will be the output, but we know it is not a valid matrix, and as I said earlier, for better matrix calculations and experience, we should use the NumPy package. Now if we have such case as 3 by 3 matrix and I have to apply some operations on each row, for example I want to have the sums of all individual rows and I want to store those 3 sums in another list. It is quite simple and we did such things a few minutes ago. But can I do it for all columns? We can access each row as each row is one element inside the nested list, but we don't have such case for the columns. So if I have to find the sum of any column, for example the first column, I will have to pick the first element of each of the row manually and put those in a list. So I'm defining c equal to 0 for column 0, which is the first column. Now I will iterate over all rows in the matrix. I'm iterating using the index and I will pick the element by specifying the row index as loop variable and the column index is fixed to variable c. So in each iteration, the column index is fixed and row index is updating. I will update the sum variable. So 5 is the sum of first column. And if I need the sum of the second column, I can set c equal to 1 and this is the sum of the second column. Because we cannot access an individual column from a nested list, so another approach can be defining a function which will return a specific column from inside the nested list. Let's name the function as column. A is the nested list and C is the column index. I will start with an empty list which will be the output column. Then I will use the same approach and iterate over the list elements using the index. I will pick the elements from the loop index row number and column index fixed to C. I will append that and will return the column. So here if I want to get the second column, I can use this function and specify the column index as 1. And this is the second column. Now here we have a lengthy task and it is related to kind of matrix we just discussed. Here we have marks of 10 students for 5 different subjects and hence we need a nested list. If it would have been 1 student for all subjects, we could use a simple list. Or if it was just 1 subject for all students, again we could use a simple list. But now we have multiple students and multiple subjects, so we need a nested list here. The rows are representing the students and the columns are representing the subjects. Once we have the complete list, we need to provide the summary of one student specified by the user. For example, if user selects roll number 5, then this is the information of roll number 5. The program must display the average marks of the student in all subjects, the maximum and the minimum marks obtained by that student, and also the subject names in which he got the maximum or the minimum marks. Likewise, user can also ask for the summary of one subject. For example, if he selects programming, the program should display the average marks of all students in that subject, the maximum and the minimum marks in that subject, and the roll numbers who got those maximum and the minimum marks. The first part is taking in marks of all students against all subjects from the user. This will show you how you can fill a nested list with the user's input. I will start with an empty list. There were 10 students, so I have a for loop with 10 iterations. One iteration is for one student, for which I need to take in marks of 5 subjects. So I should have a nested for loop with 5 iterations. Now I can take in the marks. But I want to save the marks of one student as one inner list. So I can declare an empty list before the inner for loop and I can append these marks in there. Now outside the inner for loop, the marks of one student are added in list A, so I should append that list into the major list marks. Let's test this first, but I don't want to enter 50 values, so I will test it for just 2 students. I'm entering the marks. The first 5 are for the first student and the next 5 are for the second student. So these are the 5 marks of the first student and these are of the second student. For the user, it was not a good experience since he is getting no information of the student for whom he is entering the marks. So before taking the marks of any student, we can display a message with the student roll number. It will also be good if instead of this message, he gets the name of the subject. There are 5 subjects, so I can place their names inside a list. I will copy that from other file. So subjects is the list of subject names. And over here we know that this 5 is for 5 subjects and the values are 0 to 4. And the subject names are also present at the index 0 to 4 inside the list subjects. So here we can get the element of the list subjects at the index of this loop variable. Let's run it now. We get this message that enter the marks of student 1, and then for the subjects now we have the subject names. And now it is for the second student, and the entered marks are stored in the nested list. Now I will change that to 10, but for the next calculations of one student or one subject, for different test runs we will have to enter the 50 marks first, and I don't want to do that. So instead of taking these marks from the user, I will fix those to some predefined values. I will copy that from the lab manual. This is one list written on multiple lines. I will comment this part. I want to keep the subjects list for the next logic too. Now we have that marks list. Now our program should ask the user if he wants the detail of one student or one subject. But I will start with the logic of the detail of one student instead of first asking the user for student or subject. So I will take the roll number of the student from the user. If user enters roll number 5, it means first I need to pick the information of that student from the major list, and that is this sublist, which is the 5th sublist, so I can get the particular sublist as the sublist at index r-1. You can see that sublist is selected. So this is the sublist of the selected student, and now I should process this to get the information out of it. I can find the average like this. I can find the maximum marks by applying the maximum function. Likewise for the minimum marks. Now to find the subject against the maximum or the minimum marks, we should find the index of the maximum or the minimum marks inside the list, and then we can grab the subject from the subject list at that index. I am finding the index of maximum marks from inside the sublist. And now for the minimum marks as well. Now I have the two indices, so I will pick the subject from the subject list. Now I just need to display the final result. Let's run the code. Let's enter roll number 5. This is the average marks, and maximum marks are 88 in subject calculus. Minimum marks are 69 in statistics. You should verify for some other student as well. Now for the second part where we need the similar information for one subject, the key part is getting the respective column from the major 2D list, and then the logic to find the average marks, minimum and the maximum marks, and the respective roll numbers is almost exactly same what is done here. To get a column from inside a 2D list, we can use the same function we created a few minutes ago. I will not complete the rest of the logic of this program, and I'm sure you can do it following the same steps we did for one student. Now we will write the program for Tic Tac Toe Game. I'm sure I don't need to explain what the game is. It will be a simple text-based interface and will be between two players instead of between a player and a computer. It will be a lengthy program, and in such cases we should divide our logic into multiple steps. I can write those here. First we need to have a 3x3 grid, which is the game board. We can put slot numbers inside that board. Then we have to ask the player to select a slot number between 1 to 9, and we have to fill that slot with X or O depending upon the first or the second player. And after each turn we should check the winning condition. And if a player wins, we should announce the player and end the game. If all slots are filled and there is no winner, we should declare that it ended as draw. So let's start with that. The grid, as you can see, is same as 3x3 matrix, so we can define a list for that, and we can set the elements as the slot numbers. Now we know if we will print the grid, it will be printed as a list and not as a proper grid. And also that we need to print the grid many times, like after each turn of the player we have to display the updated grid. So it will be better to create a function for that, which will simply print the grid in a specific board format. I will copy that function from other file. This function is using the grid variable of the main program and printing the elements surrounding inside horizontal and vertical lines. Let's call this function. And this is how a grid is displayed. You can see the slot numbers. Now we will ask the player to enter the slot number he wants to fill, assuming that user will enter only from 1 to 9. We can apply the condition that if he has entered 1, it means it is the element grid 0, 0 inside the list grid, so we can change that to X. Then we can have a second condition, and this time the grid element is 0, 1. And in this way we need 9 if conditions because we have 9 slots. But this is not a good approach. What if in some case we have a 5x5 grid, so we will have to write 25 if statements. Instead, we should calculate the row number and the column number from the input slot number, and that should work for all 9 slots. So let me first explain that logic. For example, if slot is 1, the column and row both should be 0. There are total 3 columns as 0, 1 and 2. So if we apply the remainder win by 3 on the slot, we will get the result as 0, 1 or 2. If slot is 1, the remainder win answer will be 1, but the column for slot 1 is 0, so we should subtract 1 from the result. And this will give column for all slots. For slot 1, column is 0. For slot 2, column is 1, which is correct. For let's say slot 6, column is -1. -1 refers to the last element of the list, and slot 6 is at the last column, so it is also correct. Let's do it for slot 8, and the column is 1. Likewise, we can calculate the row number from the slot, and we can get it by the float vn. You can think for some time and you will get the point. I can show you the rows calculated by this formula. So if slot is 8, row is 2, which is correct. Let's check it for slot number 2. And the row is 0. For 5 and 6, it should be 1. So it means we don't need 9 if statements now. We can calculate the row and column from the entered slot and can simply put X symbol on that slot. I will display the updated grid. Instead of variable name as slot, it should be P1 now. So let's run it. It's asking for the slot number. Let's enter 5 and you can see X is placed at the slot 5. Let's check one more time. I will enter 9 and you can see the updated grid. Now we need to do the same thing for the second player, and we also need to do it again and again until the game is completed. So I will prefer to create a function for that, and I will write that in a way that the same function should work for player 1 and player 2. Let's name the function as fill slot. Input argument s is the slot number, and then I'm taking the second input argument as mark, which I will specify as x for the player 1 while calling this function, and o for the player 2. So the same function will work for both players. I will calculate the row and the column number from the slot number. And instead of x, I will specify that as a second input argument mark. Now just as a side note, do you think this function can update the variable of the main program? We studied in last lesson that if a variable is not a local variable inside a function, then it will be taken from the global domain, which is the main program scope, but we cannot update that. If we have to update that inside a function, we must declare that as global inside that function. So maybe we need to do that over here, but in reality we don't need that, and that is because of the list variable. List is a mutable data type. This is something we have not studied yet. We will have a detailed lesson on mutability and immutability after 1 or 2 more lessons. So now here, after taking the slot from the player 1, we will call this function and will pass the slot entered by him and the mark as x. Let's check this. And it is working fine. Now we need to do the same thing for the player 2. And this time we will set the mark as O. We should also display a message for the player's turn. Now these statements taking the player turns should be executed until the game is over. So I will put these inside an infinite while loop, and there should be a break statement to end it when the game is over. Before adding the break statement, let's first check the progress so far. For player 1, I will select slot number 1. For player 2, I will select slot number 3. Now 2 for player 1. Now 5 for player 2. So it's working fine till now. But I want to show you a problem over here. See that the slot number 5 is filled by the player 2. But if player 1 will select slot number 5, the program will overwrite that O with X. And that is not acceptable. So before adding the remaining logic, let's first resolve this issue. I will incorporate this inside the fill slot method. We know the slots are originally filled with the numbers 1 to 9. So before placing X or O in a slot, I must check that previously the slot contains some number from 1 to 9. So I can say the slot value is in the list of numbers 1 to 9. I can also generate the list using the range function. So if the slot contains some number 1 to 9, it means it is not filled by the player, so we can update that to the player's mark. Otherwise, we will not update that. Now I also want to get this information in the main program, whether the slot is correctly filled or it was not supposed to be filled. Because if it was a wrong slot, I need to take the slot number from the same player again. So to indicate that, I can return a true when the slot is filled by the player's mark. And outside the if statement, I can return false, which will be returned when if block is not executed. So now the fill slot method has an output, so I will assign that to some variable, for example f. This is the logic of the player 1's input, so if the fill slot returns false, I should re-execute this part. I can do it using a while loop, that if f is false, keep taking the input. I should make f as false before this while loop for the first necessary iteration. Now I will do the same for the player 2. In case of wrong slot entered by the player, I should also display an appropriate message. Let's check this now. Player 1 selects slot number 1. Now if player 2 selects the same slot, you can see the message and program is asking for the slot from the same player. If entered again as 1, it will keep asking from him. Now if I enter 2 which is not filled, so slot number 2 is filled with O, and now if player 1 selects slot number 2, it will ask him to enter again. Now before adding the winning condition part, I will first go for the case when all slots get filled, so the while loop should end. For that I have to keep the track of unfilled or blank slots. So before the while loop I can declare a variable as blanks equal to 9, and whenever a slot is filled correctly, I should decrement the blanks. A slot is filled when the function fillSlot returns true, which is in the f variable, so I will decrement the count. And so for the second player. By the way, we are doing the similar things for player 1 and player 2, and there can be a logic to do it once in one while loop, and in each iteration players are changed and the mark is changed. But I'll continue like this. Now I'm still inside the infinite while loop, so if the blanks become 0, I will use a break statement. I should do it after the player 1 as well. Let's verify that. I will select all slots one by one. Now is the last slot, which is slot number 9. So when I select that, you can see the program is ended. Now we have to add the winning condition part. I will create a function for that as isWinner. It should return true if the winning condition is satisfied, no matter if it is for player 1 or player 2. The winning condition is that one player's mark on any of the complete row or any column or the main diagonal or the other diagonal. Total there are 8 possibilities of winning. We could have a general type of condition checking all rows and columns using the for loop, but here I will use the 8 conditions with OR operator. I will copy that from other file. This is one condition written on multiple lines. It will check all 3 rows and columns and the 2 diagonals that if any is having the same elements, that might be X or O, and for that it returns true, and otherwise it will return false. So after taking the input from the player, we should check if the winning condition is true. And in that case, we can display the win message and end the while loop to end the program. And similarly for the second player. Let's check that. Now if player 1 selects 9, he should win. And we get that. The only thing left is the case when no player is winner, so program should display that. We know that when all slots are filled, the infinite while loop will end, so we can check if the blanks is 0 and we can display the game is ended in draw. But if I will decide that on the basis that there is no slot left, think about the case when a player will win on the last slot. In that case also the blank slots are 0, so that's not a valid condition. Instead, I can check the status of the board outside the while loop. If that is a winning scenario status, whether fully filled or not, it means one of the player has already won. So I can check that if board is in a status of not winning, that means there was no winner. Let's try this one last time. I will avoid winning this time. And we got the message. So that's the complete program. There can be many improvements, but the main idea was showing you the use of nested list. Now we will move to the review question of this lesson. The review question is not very simple, so I will provide you with the partial code and you will complete the rest. The review question is about game of life. It is not a game, but just a visual representation of body cells which can die or can get alive. So it is a simulation of cellular automation. The cells inside our body can die, or maybe we should say that they can get dormant and they can get alive again. And we call that as the next generation of the cell. So there will be some initial state of the cell, dead or alive, and in the next generation some dead cells might get alive or vice versa. An example of 25 cells in a grid of size 5 by 5 are shown here. Live cells are represented as triangular shape and the dead cells with the circular shape. Now a cell can change its state, which is dependent on the state of its all neighboring cells. So let's first see which are the neighbors of a cell. If you see this cell, then all these adjacent cells are its neighbors. These are 8 in total, but the cells on the sides and the corner will have less than 8 neighbors. Now here are the rules by which a cell can change its state. A live cell with less than 2 live neighbors will die in the next generation. Also, a live cell with more than 3 live neighbors will die in next generation. So it means a live cell will remain alive in next generation if it has exactly 2 or 3 live neighbors. Finally, a dead cell will get alive if it has exactly 3 live neighbors. As an example, see this case. On left side we have 25 cells, and in the next generation they will change to the one shown on the right side. If you see this cell which was alive, but in the next generation it is dead. Because if you see its neighbors, there are 4 live cells there, and we had a condition if a live cell has more than 3 live neighbors, it will die. Likewise, you can verify the status of each of the cells in the next generation, and that is according to the given rules. So your task is to write a program that will create a 5x5 grid of cells, and out of those 6 will be alive and 19 will be dead, all placed randomly on the grid. Then you have to display the next generation after a little time delay, following the rules described. You actually need to display next 20 generations. Now I will first show you the program with most of the logic in there, and then we'll share a half completed program which you need to complete. This program generates the initial grid where 6 live cells are placed randomly, and then generates only one next generation. If you see this cell which is alive initially and is dead in the next generation, why? Because the cell has only one live neighbor, and that was a condition when cell dies, and you can verify other cells. Now let's see the code. Here I have 2 functions which I have collapsed, so you don't see the code in there. The first is very simple display grid, where you just need to print all 25 cells in a 5x5 grid. That should not be an issue. Then second function is the one key function for this program. It will return all neighbors of the input cell. I am specifying the input cell as the row number and the column number, and the output will be a list containing all neighboring cells. Here you will have to be careful since the cells in middle have 8 neighbors, while on the sideways or the corners a cell will have less than 8 neighbors. So the function must return correct neighbors of any cell. Here these are the 2 characters I am using to represent a live or a dead cell. Using the Unicode, you can print these and see those. Then this is the main grid having the 5 inner lists, each having the 5 dead cells character. So initially all 25 cells are dead. And here is the logic to make 6 of those as alive. So I am picking a random sample from the integers 1 to 25. And for each of those I am filling the respective grid element with live cell character. This is the same logic we used to find the row and column in Tic Tac Toe game. Grid will be displayed here. Then are the calculations for the next generation. The way I planned it is finding all cells whose state will be changed, either from dead to alive or vice versa. So I have declared these 2 lists, one for the cells needed to die in the next generation, and one for the ones needed to get alive. Then here I am scanning all 25 cells using the nested for loop for the row and the column. For each cell I first need to get the list of all of its neighbors. And then I have applied the condition where cell state will be changed, and accordingly the information of the cell in terms of the row number and the column number is appended into the respective list we declared over here. Now I need to update the cell states which we figured out. For all cells inside the list die are iterated and they are changed to the dead state, and so for the other list to change the state to alive. Then here I am just displaying the grid again, which will show the next generation. So what you need to do in the program is that you will write the logic of these 2 functions, the first of which is very simple and second needs some intelligent logic. And in the main program, instead of just one next generation, you have to display next 20 generations with a little time delay in between those, and I hope that should not be a difficult problem. You can find the codes of Tic Tac Toe game, then the task of the students and the subjects case, and the half completed code of this game of life in the description of this video. So that's all. Thank you for staying with me for this much time.